Okay guys, we're going to talk about arithmetic sequences. That is correct. I said the word arithmetic sequences. You may think I do not know how to pronounce the word arithmetic. I do. Arithmetic is a noun. Arithmetic is what you say when it's used as an adjective. As in, I am about to show you how to describe an arithmetic sequence. So, what is an arithmetic sequence? Well, here is one of them. What would I have to write down for the next number if you want to continue my pattern? If you look at my pattern, I'm guessing you would say the next number would be 11. You'd be correct. Then the next number would be 14. In fact, this list could keep going as far as I want it to go. It could stop anywhere I want it to. But it definitely has an arithmetic pattern that is generating it. And eventually I could stop it at any location I want to. So let's talk about this. This thing right here you're looking at is an arithmetic sequence. An arithmetic sequence is a list of values, that share a common difference. They share a common difference. I hear my kids singing in the background. That common difference is called D. We call that thing D. So in this case, guess what? D is 3. In this case, D is 3. You know what? Just to drive this point home, I'm going to draw out, let's say, this guy. This is also an arithmetic sequence. Can you figure out what the common difference is for it? The common difference here would be 5. Now, if you take any number in this list and you subtract the number that comes before it, you will arrive at D. I am pointing out number 11 there. 11 minus 6 is 5. What is 6 minus 1? It's 5. What is 1 minus negative 4? It is 5. So sometimes when you're looking at an arithmetic sequence, it's real obvious what the common difference is. And sometimes when you look at it, it is not very easy to see what the common difference is. So, for example, this list right here that I am going to show you. And by the way, those are decimal points. Now you're looking at it going, well, it's not quite as easy for me to do this mentally. And it doesn't seem like it's increasing this time. It looks like it's getting smaller and smaller as it goes down the list. So how would I figure out what the common difference is? The common difference, the word difference starts with the letter D. So that's why they call it D. Well, take any number in the list. I'm going to take 0.97 and subtract the one that came before it. And if you do that, you will get negative 1.6. Now here's the thing. This guy, take away the one that came before it, gives me negative 1.6. But you have to verify that what you're actually looking at is following that pattern. So how do you verify that it is a common difference? Well, that means that when I do 2.57 take away 4.17, I am able to get negative 1.6 again. So on my calculator, I take 2.57 minus 4.17, and sure enough, when I hit enter, it comes up with negative 1.6 again. So what I am trying to tell you is there is this animal out there in Mathville where you have patterns of numbers. And the pattern, if it is based on adding or subtracting the same value over and over again, like here, when I say, look, starts at 2, then goes to 5, then goes to 8, that one's very easy to see that the common difference is 3. I don't have to grab a calculator and say 14 minus 11 is 3. Hey, 11 minus 8 is 3. I don't have to do that. On this one, it's pretty easy, and I can see it. The second one, I can still do that fairly easy. But this third one here, that was not easy. You're not walking around going, you know what, that looks like negative 1.6 is the D value. So, what we do is these things called arithmetic sequences. Well, they have their own separate way to be described. They have their own special rhyme and reason, the way they, are illustrated for people. Part of what they are is you need to know the D value. That is totally true. Part of what they are, you need to know the D value. So here we go. I'm going to talk a little bit more in depth because this first guy, he's a real easy example to see how things are working, so we're going to talk about him as our first example. So I'm going to scroll down and I'm going to say, let's take that same guy, and I am going to tell you a little story about a guy named Carl Friedrich Gauss. Carl Friedrich Gauss was a German mathematician who was responsible for coming up with all this stuff that you're about to learn. He said, you know what? I see this is the very first number in my list. I am going to call this A sub 1, or A1, because this is an arithmetic list, and that's the first number in it. I, Carl Friedrich Gauss, will now call this A sub 2, because it's the second number in an arithmetic list. I will now call this A3. I will call this A4. And if you are wondering how long this list goes, well, this list could go 5, 6, 7, 8. It could go A sub any number I want it to go to. So hold on to your hats. You're about to learn about this formula. This is a formula that you will need to know to answer questions about arithmetic sequences. This formula right here has 3 separate names. One of the names of this is called the nth term. Some books will say this is the nth term definition. Ooh, let's add that to the list. So sometimes they call it the nth term. Sometimes they call it the nth term definition. And then some books call it the rule writing formula. I will call it whatever I want. I will either use this, or this to describe it. And if I do, you should know those vocabulary terms. I had a little discussion about flashcards earlier this week, and flashcards is a good thing. You would want to have this on a flashcard, like what is the nth term in an arithmetic sequence? And then on the other side of the flashcard, you could have this formula. Now let me explain what this means, because in this formula you see some A sub n, you see an A sub 1, you see an n minus 1 in parentheses times d, and d is the common difference. So there is a formula that decides these sequences. You're looking at the formula, but how do we get there? Well, it's going to take a little bit, but hold on, and I'll try and explain what all this stuff is talking about. See, this dude who invented all this thought, he was like, I am going to tell you all about sequences. But I'm going to make up all the rules since nobody else has made up all these rules yet. So, this guy is technically called the nth term. If you want to know any number in the list, right? All you have to do is count until you hit it. So if he said, I want my list to end at 7, well, then this thing right here would be called a sub 7. And I could tell you the name of a sub 7. I totally could. But I would have to know what a sub 6 was. I'd have to know what a sub 5 was. Look, I already know what a sub 4 is. I do. So anyway, the thing is, I can't tell you what the 7th number in the list would be unless I knew what the 6th number in the list was. I couldn't tell you what the 6th number was unless I knew the 5th number, etc., etc. Well, you go, well, that's not a big deal. I can count out 7 numbers and get it right. You totally could. That is true. But what if somebody said, I would like to know what the 100th number in that list is? Well, you better have a strategy then, because that's going to be extremely time-consuming. So, let me go back to this. See, Gauss said to himself, he said, you know what? That will signify the end of my list. The number that came right before that would be the a sub n minus 1, the 1 right before it. See, if n was 7, if it was 7, this would be 7 minus 1. That would make it a 6, right? So I have to kind of give you a little background on the stuff he made up to keep track of stuff here. But he always started with little a, because everything he did originally in his career was about arithmetic things, and the word arithmetic starts with the letter A. So there's no mystery there. So, a sub 1, that means the first number in the list. That's what it means. A sub 2 means the second number, etc. So like when we get down to these guys, it's like this represents the end, wherever the end might be, could be at 10. I want my list to stop at 10. Then n is 10. What would that make this guy? The 1 right before it, that would make that guy the 9th number in the list. What if it ends? What if the n was at 20? Well, then this guy would be the 19th number in the list because he's n minus 1. If n is 20, n minus 1 represents 19. So what I'm trying to get at is he had like a scheme for counting this stuff up. And he wrote it the way he wanted to. So we all have to adopt to his idea. And at first, if you see it written out and nobody tells you how to read it, you go, I have no idea what you're talking about, buddy. So let me try and explain how to read it, because the whole object of this unit is learning about number patterns. And the easiest number pattern we have is an arithmetic sequence. So let me tell you something here. If you want to describe a sequence for somebody, you got 3 ways you can do it. You either write a list of numbers so they can figure out the pattern. That's all I've done so far. I've given you guys a list of numbers that you can figure out a pattern. That is one way. So the first way is just make a list. Then there There's a second way, and this is the way that looks really weird, but it's not hard to write. It's very weird. It's called a recursive definition. Not an nth term definition. This is called a recursive definition. Now, a recursive definition has a format to it, okay? Follow the format that I show you. You will have to do this on the first assignment. You'll have to write recursive definitions. Good thing for you, it's really easy to do them. Here's the format. You say a sub 1. Now, what does a sub 1 represent? It represents the first number in our list, or we call it the first term. Then, if you're going to write a recursive definition, you always write this part. This says if you want to know any number, a sub n, if you want to know any number in the list, it's going to be equal to the, well, what is this guy? The one that comes right before that number plus d. That's how a recursive definition is read. Now, when I write out just the symbolism here, when I write out just the symbolism, it looks really complicated, spooky, and scary at the same time, but it's not hard to do. I am going to write the recursive definition describing this list right here, okay? I'm going to do that. Watch. I do not like to write out the words recursive definition because I don't like to spell. So I abbreviate and I just say rec period def period, rec def. But here's how it's written. So I would say a1 equals 2, a sub n equals a sub n minus 1 plus 3. This is the recursive definition for my sequence. What sequence? The one that looks like this up above. What? Okay, this is a recursive definition. It tells you, hey, start your list at 2. A1. A sub 1 means the first number in the list, first term. Start your list at 2. Okay, so that means write down the number 2 first. Okay. Then, if you want to know any other number in the list, you better know the one number that came before it, then add 3 to it. Oh, so if I started at the number 2, and I wanted to know the next number in the list, or sorry, if I wanted to know the next number in the list, I started at 2, I add 3 to it, I get 5. Yeah, you do. Well, what if I want to know the next one? Well, take the one you just finished. Take the 5, add 3 to it, you'll get 8. If you want to know any number in the list, all you have to do is take the one before it and add 3 to it. That's what that means. That's all that is trying to say to you. Now, you might say, oh, crap, I'm totally confused. But hang on. Really, let me show you how easy this can be. I am going to start you off with a recursive definition. I'm just going to make something up. I'm going to say a1 equals 6, a sub n equals a sub n minus 1 plus 7. So, this is called a recursive definition. This is one of the ways you can describe an arithmetic sequence. What does this sequence look like? Well, it says here a1 is 6, so start my list at 6. And then it says here, if you want to know any number, you better take the one that came before it and add 7. So if I want to know what this number is, I better add 7 to the one that came before it. I will get 13. If I want to know the next one, I would take 13 and add 7 to it, and I'd get 20. And if I want to know the next one, I would get 27. And I could keep doing this as long as I want. I'm going to write another recursive definition. I am going to make this up off the top of my head, and I am not even thinking about what the list is going to look like until I am done. I don't know, how about a 5? What the heck? Okay. So what am I trying to get at? I'm trying to show you how a recursive definition is used to generate a sequence. What is the first number in this list if I were to write it out this way? Well, the first number in the list would be -3. I want to know what this next number is. If you want to know what this next number is, you take the one that you already have and add 5 to it. Oh, so it's 2. What if I add 5 again? Well, then I'll get 7. What if I add 5 again? Well, you'll get 12, etc., etc., etc. So, let's get back to it. There are 3 ways to describe a sequence. There are 3 ways to describe a sequence. One of them is you just show somebody the list. That's the easiest way, but it's very non-useful. The second way is called a recursive definition. What do? You always follow the same format. Just like I did. That's the format you use. Well, I just, okay, I plugged numbers in the format. Yes, you do. The more we play with this, the better you get at it, and then the more I can share. Really, I can't share everything about it right away. All I want to accomplish with this video is so that if I give you some problems and I say, could you read this or write this definition or whatever, could you? And by the time we're done, I hope you'll say, yeah, this is not that bad. Okay, so the third way is, how do you describe a sequence? You write the rule. Or some books will say, write the nth term definition. Remember, there were 3 synonyms. Writing a rule, writing an nth term definition, or writing an nth term. Now, this one is the one that's the most complicated, but the good news is it's not that complicated. But it is the one that is the most complicated. But we cannot do it without this formula I wrote down earlier. The formula I am speaking of is this formula here. So a sub n equals a1 plus n minus 1 times d. This guy is called the rule writing formula, right? So, how does this work? Well, let's write a couple rules. Let's practice and we'll see. I'm going to take the last one we did. What the heck? This guy right here, because I have some room. I want to not write a recursive definition. I don't want to make a list. I want to write a rule. So I say unto you, if you want to know what any number in this list is, it will be equal to the first number plus n minus 1 times whatever the d value is. Now, here's the good stuff. If somebody writes a list, I can tell you what the A1 value is already. Or if somebody gives me a recursive definition, I can tell you what the A1 value is already. Visually, I can see the pattern develop here that they're adding 5 each time. That is called the common difference, or D. Or if I look at the recursive definition, whatever thing is right there, that's D. So what do I do with all that information? Well, I'm going to replace some stuff. I'm going to substitute. I'm going to say A1 plus n minus 1 times D. What is this going to equal for me? Well, it's going to equal whatever number I want to know in the list. How do you say? Well, let me show you. This is where it becomes easy peasy because, oh, come on, black pen. All I have to do is clean this up. See, this is just parentheses with a number I distribute, so I get -3 plus 5n minus 5. What's it equal? It equals a sub n. Can I combine these two guys and put them together? You sure can. So I would say 5n minus 8. This dude right here is my nth term. This dude right here is my rule. This is the third way to describe this list. Now you might go, well, what does that mean? Well, here's what I'm trying to say. If you plug in 1 right there, if you plug in 1 for n, that means you're trying to tell me what the first number is, right? Because if I plug in 1 wherever I see an n, this translates into a1 equals 5 times 1 minus 8. Well, what is that? That's equal to negative 3. You're right, it is. Check it out. What if I wanted to know the second number in the list? Well, I could plug in 2, right? That would be plugging in a 2. Well, that would just be 5 times 2 minus 8. Well, that's 2. Oh my gosh, that is true. It's 2. And I could keep doing this. If I want to know what the third number in the list is, I plug in 3. And then I'd go 15, take away 8. Well, that's 7. Oh my gosh, look, that is the third number in the list. Oh, I could do the fourth number. Yeah, you could. You could also do the 50th number. See, here's where a rule gets to be extremely powerful. It is extremely powerful. I want to know what the 50th number is. Well, it would just be 5 times 50 minus 8. So I go, oh, 250 minus 8, so it's 242. Now, just stop for a second and think to yourself. If you didn't know how to write a rule, if you didn't know this trick existed, you'd have to write out 49 numbers to find out what the 50th number is. See, writing a list of numbers that has a pattern is definitely a cool thing when you're talking about numerology and, ooh, I'm just talking about numbers, having fun with numbers. Writing a recursive definition, that's a way to describe this list also. But you know what? If somebody says, I need to know what the 50th number in the list is, this and this don't get you very far. It's writing the rule, using this formula to create a rule. That's when you're making the money. That's when you're getting paid the big bucks. So let's try this again. Now that you're starting to see there's a big, wide, open picture here. And what is the thing I'm trying to get across to you? Not that there was a dude in, 1671 or something, I think it was, Carl Friedrich Gauss in Germany, who was very into playing with numbers. No. What I'm trying to get across to you is there are things out there called arithmetic sequences. I'm just going to make another one up, 4, and then I'm going to add 3 each time. So I'm going to say 7, 10, 13, and then I'm going to just have you practice some skills. I'm going to say, hey, based on that list, can you write me a recursive definition? Can you? Well, how do I do it? Well, I go A1 equals first term. Well, what is the first term? It's 4. So I go, oh, they don't want me to write the words first term. They want me to write down the first term. And then what? If I want to know any number in the list, I need to know the one that came before that number, and then I add D to it, right? Because D, the common difference is 3. That's it. I'm done. That's a recursive definition. Good to go. But what if they say, I want to know the 100th number in the list? I go, oh man, that's a big task. I don't want to know. I don't know what the 100th number is. What about the 20th number? That's still a big task. I don't want to write out 19 numbers, so what do I do instead? I write a rule. And I say the rule is based on this formula. And what do they want me to put here? They want me to put A1. What do they want me to put here? They want me to put D. And then what do? I say, well, this rule is called the nth term. That's why a sub n, the number in the list, nth term, is equal to a1 plus n minus 1 times d. And then I go like this, and so I get 4 plus 3n minus 3. I can smush these two pieces together and get 3n plus 1. This is now called my rule, or my nth term, or whatever, but that is another way to describe a sequence. You either tell somebody the list, what does it look like? You tell somebody a recursive definition, or you tell them a rule. Those are the three ways to describe a arithmetic sequence. But when somebody says, okay, you're so smart, tell me what the 100th number in this list is, there's only one place I want to go to get that piece of information, and that is right here in my rule. Because if I want to know what the 100th number in the list is, I am going to say, oh, that's easy. 3 times n plus 1. All I'm doing is substituting. And I go, oh, the 100th number in this list would be 301. Thank you very much. I'm going home. And you'd be done. So, this is basically what I need you guys to practice for this first lesson. And once you get the hang of it, I'm sure you're going to agree this is not the worst thing. This is one of the reasons why this unit is just so darn quick. We're going to be through this unit before you know it. But let's try it one more time just for fun. And this time I'm going to do something like 11, and then 5, negative 1. And you know what? Here's the thing. Customarily, all I have to do is show you 3 numbers in a list. I could keep writing out numbers, but I'm lazy. It's been a long day. I'm tired. You know, this is what I'm doing at 7 p.m. at night. So anyway, it's going down by 6 each time. Do you see that? And if you don't, you could take any number in the list, subtract the one that came before it, you get the same number every time. 5 take away 11, oh, I got the same number again. That guy is the same number, so it's called a common difference. We call it D. Okay, I'm going to get this out of my way so I have some room. Get out of my way, I'm erasing it. Ooh, oh my God, that one didn't want to go away. What's the first number in this list? Well, that's easy. It's right there, and it's always called a sub 1. So if you have a sub 1 and you have D, if you have these two ingredients, I'm going to get rid of this right here. If you have those two ingredients, you can now do the rest of the descriptions for me. You can write a recursive definition. What's that one again? Where I go A1 equals, you just tell me where it starts, 11. And then I always have to write this part, A sub n equals A sub n minus 1 plus, what is it, D? Wait, D is a negative 6. Can I just do this instead? Instead of saying plus negative 6, can I say minus 6? And I would say, yes, totally, that's what Gauss would do himself. So anyway, I've got that. That's my recursive definition. Not hard to write, but super hard to read. If somebody says, what's the 50th number in the list? You go, oh man, I got to know all 49 numbers. Wait, I don't even know the 49th number. I have to know all 48 numbers. Oh my God, I don't even know that. I'd have to know. It's really bad. So we don't do that. What do we do instead? We say, thank you, Gauss, for coming up with this beautiful formula called the rule, or the nth term, or, whoops, sorry, I didn't mean to write another n. Duh. I got excited while I was writing, and I lost track of my stuff. So here we go. We write rules. This is where we get the big bucks. We're like, I'm going to plug in an 11 here. I'm going to plug in a negative 6 here, and I'm going to clean it up. I'm going to distribute. I'm going to end up with this, it looks like. And then I'm going to say my rule, oops, come on. My rule is negative 6n plus 17. And you go, I wonder if that's right. So here's the nice thing about arithmetic sequences. If you write a rule and you want to know if you're correct, all you have to do is plug in 1. If you plug in 1, what's it going to tell you? It's going to tell you A1. And if I plug in 1 right here, I'm going to get negative 6 times 1 plus 17. That's 11. That is A1. So what I'm trying to say is this. Rules are always self-checking. They will always check themselves before they wreck themselves. That is true. That was Grandmaster Flash, by the way, that did check yourself before you wreck yourself. So here we go. I think I asked you for the 20th number in the list. On the practice, I ask you to do this. On the practice, I'll say, hey, write me one of these. Hey, could you write me one of these? Hey, and then I pick on some random weird number and I go find the 20th number in the list. So if I want to know that, what would I do? For this particular example, I would go negative 6 times 20 plus 17. And that gives me negative 120 plus 17, which is a grand total of negative 103. That's the 20th number in the list. So, here's the dealio, yo. This is not hard stuff if you know how to write it out. It's not. You can figure it out. But here's the rules of the game. Here's the thing we're going to do the first time through. If I give you a list, I might ask you for this thing or that thing, and you should be able to do it. But what if I start you like this? What if I say, hey, A1 equals 4. A sub n equals A sub n minus 1 plus 2. And I say, hey, what are the first 3 numbers in that list? Your brain has to go, wait a minute, I know there's only 3 ways to describe a sequence. He gave me what is called a recursive definition. I almost said raccoon, I don't know why. Anyway, and that means this starts at 4. And if I want to know the next number, this part says, hey buddy, you want to know the next number? You better add a 2 to that. You better add a 2 to that. Oh, by the way, that is 3 numbers. That's what you asked for. There they are. Bam! There they are. Or I might start you with something like this and say, could you write the rule for me? And I say, I so could write the rule for you because the rule is always based on this formula, which, by the way, do you see how quick I write this thing down? Flashcard City. I don't know, how do they say that in Spain? Oh, they say flashcard, but they just happen to be in Spain when they say it. Huh, you thought I said, how did they say that in Spanish? But I didn't, I said Spain. It's a dumb joke anyway. All right, so A sub n equals 4 plus n minus 1 times 2, and then I work it out, and I go 4 plus 2n minus 2. Crunch the numbers together, because if you don't, I will mark you wrong, because I talk about polite mathematics, and that is a polite rule. When you write a rule for somebody, you don't make them combine the stuff. You do it for them. And then I will ask you, hey, what is the 50th number in this list? Something random like that. And if you go, hey, I could do that. That's just 2 times 50 plus 2. That's 102. Bam, done. And you'd be correct. So in this assignment, I'm going to do that to you. But I do want to make sure that you are forewarned. I could do this to you. Wait a minute. That was one of the worst looking fancy brackets ever. By the way, most of you guys right now may have figured out how difficult it is to draw the fancy bracket. Fancy brackets are not easy to draw. Some of you are probably really good at it because you have some kind of artistic penmanship. And then some of you guys are like me, where you were like sent to math camp all summer just so you could learn how to draw fancy brackets correctly. So here we go. Fancy brackets and all. Oh my God, what is that? Okay. Here. So, see this one? And I say, what's the 50th number in the list? Guess what? Now you got to work. I don't know where to start. Well, start with, take any number in the list. Any number. Subtract the one that came before it. You will get a number. Take any number in the list. Subtract what came before it. You better get that same number, or else that thing is not arithmetic. Since I was able to take any number in the list, subtract the one that came before it, I got this. Take any number in the list, subtract the one that came before it, I got this. I know my common difference is 3/8. I already know by looking at it that that is my A1. So now if somebody says, hey, find the 50th number in the list, I am not going to say, oh, I could find the 50th number. Just let me write a good old-fashioned recursive definition, because when I write one of these, it's super easy to use this format to come up with the 50th number. No, it's not, but it is a way to describe a sequence, and you have to know how to do it, because it is called a recursive definition, and they are all over calculus. Yes, they are. And then there's something called the rule, which would be the easier thing to use if you want to know the 50th term. But I have A1. I have 8 sub n equals A1 plus n minus 1 times d. So what am I going to put here? I'm going to put 1/2 plus n minus 1 times d. And like I said, I am not going to be a slouch. I am going to get common denominators and all that good stuff. So here, I know 1/2. I'm just going to do it right away. It's going to be 4/8 plus 3/8 times n minus 3/8. Then I'm going to combine these, and I'm going to say 3/8 n minus 1/8. That is a politely written rule. And if you don't write it politely, you will get marked wrong. End of story. That's polite. Now, if somebody says, I want to know what the 50th number is, all they have to do is put 50 right there, and they could use their calculator from there if they really want to. And I would say, hey, that's the same as 150 eighths minus 1/8 gives me 149 eighths. That would be the 50th number in the list. And I could write it as a mixed number or an improper. I don't care. But I am exhausted. That's a long way to go to get there. So, let's see what we got. Here we go, up to the top. Wham. Arithmetic sequences. Yeah. 10:02 a.m. That timestamp is so wrong. Okay, anyway, here we go. Unit 5. Congratulations, we made it to Unit 5, Video 1. The first set of problems, it says, write the recursive definition, rule, and 20th term for each of the following arithmetic sequences. So there's 8 practice problems right there. What are you going to do? You're going to write a recursive definition. You're going to write a rule. Then you're going to tell me the 20th number. Whoop, I don't know why it said that. Then, down below it says, use the given rule. So I gave you a rule to write the first 3 numbers of the sequence. Then, hey, while you're at it, write the recursive definition for these 4 guys also. Then it says, write the first 3 terms of each sequence based on the provided recursive definition. Now, this part down here is only for number 17. I don't want anyone to get confused. For number 17, it says, if A1 equals 5 and A sub n equals A sub n minus 1 plus 8, this one just says, what would the 50th term be? What is the 50th term? Don't do it for all of these up here. You don't have to. Then what do? You check. You make sure you're right. And this is called the answer key for this video. So once again, oh, and you can see I've flubbed up here, and then I scratched it out. That's the answer I want you to check, though, right there. Anyway, there's my answer key. There's these questions. And last but not least, there's, whoops, oh my gosh, there's these questions. And that's 45 minutes of fun in that video. All right, guys. Catch you on the flip side.